Hello, everybody. What we're going to be looking at today is going to be just kind of an intro to your Programming 4 assignment. Okay, so we're going to do most of this, of course, just on the computer, but since it involves graphs and stuff and kind of visual, then I wanted to do a little video that just kind of talked you through what the code is that we're going to be trying to do here. So what we're going to be doing is this. So we're going to basically write code to find uh, Euler circuits in a graph, and we have an algorithm for it. Um, but oh, actually, I don't have the algorithm printed right here. Hold on a second. Um, Let me see if I can get the book up on my screen as well. Oh, I hope I didn't. Okay. Oh no. I may have just canceled a video from uploading on YouTube. If so, that would be bad. No, I think it's good. Okay. Um, okay, so sorry about that. Back to this. So what we're looking at is it's in section, I want to say 10.4, something like that. Let me just bring that up. 10.5, actually 10.5. Make bigger. Yeah. Okay. So first of all, what are we talking about here? So the idea is if you've got a graph. So here's a graph. I think this one has an Euler circuit. Let me see. Um, well, no, it can't. Um, so that could have an Euler path, but not an Euler circuit. So I don't want that one. I need one where every vertex is the even degree. Okay, let's just do this. There, there, there. Let's go there, 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 and then nope, there. Okay, I think every vertex on this graph has an even degree. Let's just check. That's 2, 1, 2, 3, 4. This is 4. That's 2, 1, 2, 3, 4. That's 4, and then this is 2 again, right? And that was necessary. So we learned in 10.5 that if every vertex has even degree, then there is an Euler circuit in the graph. Now, what is an Euler circuit? So an Euler circuit is going to be a circuit that uses every edge and takes you back to the starting vertex. So remember, so Euler circuit. Circuit. So a circuit, right, which is just a sequence of edges that uses every edge at exactly one time and takes you back to the starting vertex at the end. That's not really a definition that that's not really a good definition that I put there, but that's what it is. So like, for example, the graph that we just drew must have one because every vertex has even degree. So like if I just start here at 2 and I just start tracing edges, I can go from 2 to 4, and then from 4 I can go to 4. Sorry, they're not numbered, but you can go to that vertex. Then from that vertex, I can go here, and then I can go over here, then I can go here, and then here, and then here. And so I traced every edge once, and I started and ended at this vertex, which did not have a name. Okay, so that's an example of an Euler circuit, and we want to be able to find one just with a program, and that's a little bit tricky. And so um, the procedure is this. So this is from the book. I should just copy paste it, but I can't right now. So I'm just going to find Euler circuits. Okay, so they say, so procedure, they call it Euler. You give it a graph G, which it needs to, all vertices have even degree, because that's necessary for this to have a solution, right? So you can't just give it any graph or it'll fail. And then it says that this is the procedure. So it says circuit equals a circuit in G, beginning at some vertex. Okay. And then from there, it defines a new graph H to be G with all edges from the circuit removed. Okay. And then it goes while, I should have put this over here. Actually, I can do that, can't I? Do the miracle of modern computing. It's not working. Okay. While H has edges, then what you do is you come up with a new circuit, subcircuit, a circuit in H, beginning at a vertex in H that is also in G. No, it's also in circuit. And then after you have that subcircuit, then you make H is going to be H with the edges from the subcircuit removed. And then circuit is going to be circuit with subcircuit inserted at, they say, appropriate vertex. And that's done with the while, and then finally it returns circuit. And I realized that this was very messy and I wasn't explaining it very much, but the point is that that's what we're going to talk about now, like what's going on here. So let me make a simpler. Well, that's too simple. Let's make a simpler one here just to look at. To give you an idea of how this would work. Duplicate. So here's going to be an example of what's supposed to be going on. So I'm going to give these all names. So I'm going to call the vertices are just going to be numbered because that's how we're going to do this on a computer. So I'm going to go 1, 2, 3, 4, 5, 6, 7. Those are your vertices. So vertices are numbered. And actually we can I think maybe the way to do this is going to be to do this as much like how we're going to do it on a computer in when we write our code. So this graph here, how are we going to represent it? So the way we're going to represent this graph on the computer, this is the easiest way I thought of to do this. There's, other ways, but the way I thought to represent this is just for every edge connects two vertices, right? So if you know the edge, if you know both vertices, then that tells you the edge. So like this edge right here is vertex 1 to vertex 2. So that's 1, 2. And so if I just put 1, 2 into a matrix, that's really frustrating the way it does that. That's going to be fine for my for that first edge. And then you just keep doing that. And they don't have to be in any special order, right? So we just did this one. Now, what about this one? That's 2 to 4. 2, 4, right? And it doesn't matter what order you put them in, so you can keep going. So what about this one, 4, 5? Or this one, 4, 3? We'll do 4, 3. Now, one problem you might notice already is that 4, 3 and 3, 4 are actually the same edge. So, that's something. What do we got this? We got 3 to 1. And I'm not paying attention about the order or anything like that. What's the next one? How about this one? 4 to 5. 4, 5. 5, 6. 6, 7. 7, 4. All right. So that's how we're going to put our graph in there. Did I do 3, 1? Yeah, I did. Okay. So edges, G is stored as a matrix, like the one we just drew, like so. Each row is an edge. The numbers are the vertex. The numbers are the vertices that the edge is between. Right, e.g., 2, 4 is an edge between vertex 2 and vertex 4. Okay, so that's how we're going to store our matrix. Okay, now what are we supposed to be doing here? So you have to look at what the first thing to do is. So if you look at this code here, it says the first thing we have to do is we need to find a circuit, any circuit. And so it turns out that when you're looking for a circuit in a graph, a circuit means just a sequence of edges, you get back to where you start. All you have to do is just follow along edges and you'll eventually get back to where you started. Okay, so like what you would do, for example, is like, let's say, find a circuit. You pick any starting vertex. So I'm just going to start at 1. Okay, so what you do is you go through this list here and you'll eventually find a 1, right? You find that edge. So you find, so you're going to look through G, the matrix, right? And find 1, 2, all right? So that tells you you started at 1, now you're at vertex 2. Right? So then you look through G for a 2, right? So the first time through, what you were doing was you were looking for a 1, right? And we highlighted that. So now you start at the beginning again and you look through here until you find a 2, which you find a 2 right away. So you get that. Now you look through G for a 4, right? Because we were coming from 2, so we must be at 4. Of course, that's the next one. So you find 4, 3. So then you look through G for a 3, which you'll find 3, 1, it looks like. So you find this. And now you're back to where you started, so you stop. So stop. Okay. So what you got now is you've got circuit at this point is going to be whatever the edges are that we just found. 1, 2, 2, 4, 4, 3, 3, 1. Now they happen to be the first edges here because of the way that I listed them, right? I listed around this way, and then I think I listed around this way. So that's kind of dumb. But even if these were in a completely different order, we still would have found a circuit. Might not have been the exact same one. We could have gone all the way around, in which case we would have been done with the whole problem. But so you do that and you find a circuit. And so we need a code that does that. But this is what this is. Okay. And then once it does that, we need to make H, which is going to be G, but we have to remove everything from the circuit. Okay. So then we have to remove the circuit from G. So what you're going to do is, of course, you have circuit is this, right? And G is up here, but I actually highlighted the circuit, right? The yellow is the circuit. So you remove all that. So if you remove all that, you're just going to have this bottom part left. So you're going to end up with just G is going to be 4, 5, 5, 6, 6, 7, 7, 4. Right? So this is what you have for your variables. What's H? Sorry, what's H? Oh, H is that, right? H is G with the circuit group. Sorry. That's to make H. So that is H. All right, so now you got H and you got a circuit. And you also have G. So then what you do is while H has edges, then we kind of go through the same process. Subcircuit is a circuit in H, beginning at a vertex in H that is also in circuit. So what you have to do is, first thing you're going to do is compare H and circuit to see which vertex they have in common. So they're right there. So if you look at this and you look at this, you say, well, what vertex in here is also in here? And it doesn't matter if there's more than one, you just need to find one. So what do you see? Right? So like there's a 1 in circuit, no 1. There's a 2 in circuit, no 2s. There's a 4 in circuit. Oh, there's a 4. Right? So 4 is in both of these. So you find that there's a 4 in both of them, right? So we find 4. Okay, why do we need that? Because according to the pseudocode here, it says subcircuit needs to be a circuit in H beginning at a vertex in H that is also in circuit. So you need a common vertex between between circuit and H. So we need to find that first. And then once we find it, now what you do is find a circuit in H starting at that 4. Now, again, we're really lucky that, 4 just happens to be the beginning here. Actually, like, I'm going to even change this a little bit. This has no justification at all, but like, let's just say that I had written these all in a different order, okay? So, like, let's say I had gone 5, 6, 7, 4, 7, 6, 5, 6, 7, 4, 6, 7, 4, 5. Now, there's no reason why we should be using that, but I'm going to use this for my H instead, just to show you, right? So that way it wouldn't be, the edges wouldn't be written in that same order, but it's the same graph. Okay, so like now, if I say find a circuit in H starting at 4, what you would do is the exact same thing we did here, where you just keep looking through the graph and you find edges, right? So like if I look through here, so we look through H, for a 4, right? What do we find? We would find 7, 4, right? So you find 7, 4, 7, 4. Now you're at vertex 7 because you were looking for the 4, so now you found a 7. So look through H for a 7, but not the one that we just found. So you look through here for a 7, you find 6, 7. Now you're going to look for a 6. So you look for a 6, you find 5, 6. Now you look for a 5. You're going to find the last one, 4, 5. And then you're done because you're back at 4, and that's a circuit because we were starting at 4 and ending at 4. Done because that's a circuit. So what that tells you is you've got subcircuit now was what we were looking for. So subcircuit is what? It's what we just found here. So it's these. So first one was 7, 4, 6, 7, 5, 6, 4, 5. Okay? And then that's a subcircuit. What do we do? So we did this. Now H is H with the edges from subcircuit removed. Now if you compare this though, if this is subcircuit and this is H, and you remove these edges from H, well, there's 4 edges here in subcircuit, there's 4 edges here in H. If you remove all of these from these, you're going to be crossing them all off the list, right? We use them all. So what happens is when you remove subcircuit from H, what you're going to get is that subcircuit is subcircuit, but what you're going to get for H in this case is empty, right? Because there's nothing there. So we've done this. And then now what it says to do is it says circuit equals circuit with subcircuit inserted at the appropriate vertex. What's that? So we're going to insert subcircuit at appropriate vertex in circuit. All right, so what do we got? This is your subcircuit. Where's the circuit? Let's find the circuit. Here it is. Here's circuit. The appropriate vertex vertex is the vertex they share. So what you would do is you would find what vertex do they share. So in this case, so it's what vertex do these both have? Right? Four? Is that what they have? I think that's what they have. So it's 4. And then what you do is that means, so after the 4 in circuit, copy the entire subcircuit there. So like if I color these, for example, if these are all green and these are all orange, and the one they have in common is 4, right? So what you're doing is you would say, okay, well, once I find that 4, then right here, this is where subcircuit goes. So what you get is you start out with your circuit. So you go 1, 2, 2, 4. That part's normal. Those were from circuit, so I'll color them orange. At that point, you see the 4. That tells you that now you should copy all of the subcircuit. So then you come over here and this entire thing comes right here. So you go 7, 4, 6, 7, 5, 6, 4, 5. Oops, not intended. So there's your subcircuit. And then after you do your subcircuit, then you go back here and you finish off the rest of the circuit. So 4, 3, 3, 1. Right? So this is where your subcircuit goes. Okay, now that's pretty complicated. Like this is all pretty complicated here, but this is what you do. And then when you're done, so now actually you'll notice that H was empty, right? So when H is empty, you're done. And circuit should be an Euler circuit, which is what we were trying to find. So let's just see if that's the case. Let me find the graph here. Where's the original graph? Duplicate it. Come down here. And let's see what happens here. Yeah. So let me delete all the colors on here and see if that makes sense. All right. So just trying to follow this through. We're just going to take these by hand here. So first thing you have is edge 1 to 2. Okay. Then edge 2 to 4. 2 to 4. So you're at 4. Next edge 7 to 4. That was from the subcircuit. So that's this one. Right? So this is still tracing the right. We went here to here to here to here. We're at 7. Continue on. 7 to 6 or 6 to 7, the way we wrote it. 6 to 7. 6 to 7, 5 to 6, 5 to 6, 4, 5. So we're back here. So far we did this. We went here to here to here to here to here to here to here. We're at 4. And then we go 4, 3. And then 3, 1. Back to the start. So yeah, so this is an Euler circuit. Okay. And that's a pretty complicated process to find that Euler circuit. But if you think about what kinds of things we needed, you'll see that this is really like a couple of tasks that would be nice if there was just a function to call the function. And that's what you have in the homework. So if I actually look at programming 4, what you'll see is I ask you to do the following, right? So in programming 4, I've split, the harder, the more challenging stuff to write into individual functions. Into smaller tasks. So what are those smaller tasks? So first of all, the function, I think I just wrote the function. So the main function, which is just Euler e.g., is already written. And we'll look at it next time, but it literally just copies the pseudocode, but in MATLAB. But it calls a bunch of other functions. So here's you have to write function make circuit e.g. to v. And so what this function is going to do is actually, oh, come on. It's ridiculous. So you write this function. So what is this function going to do? Well, this function is going to, given a graph, e.g. because it's the edges of G, was my thinking. Given a graph, e.g., you will find a circuit that starts and ends at V. Now, why does it have to be V? Because think about the pseudocode up here. When we were doing the subcircuit, we had to compare H and circuit to see which vertex they have in common, 4, and then find a circuit in H starting at 4, right? So you have to be able to specify where the circuit starts, right? The reason this worked here was because we knew that we knew that 4 was a vertex where you could find another circuit, and then you could find that circuit and put it back in where it goes. That didn't sound right, but that's the idea. So you need to be able to specify a vertex. So that's a task that we had to do. So you're going to write that function. Okay. Another task is you have to remove edges a lot, right? So there's a function called remove edges. And again, you give it the edges from a graph. So that's why. Um, and also you have to give it a circuit. And then what it does is um, the following. So it's going to remove the edges in circuit from EG, and the result is going to be EH. Well, why do we need that? Well, again, you come up to your pseudocode, and in the pseudocode, right, this line right here, H equals G with the edges from circuit removed. So we want a function that just does that. And then also down here, you have H with edges from subcircuit removed, which is that's the same function, right? So like the function make circuit does this, making a circuit at G, and it does this, subcircuit a circuit in H, right? So make circuit does this right here and this right here, and then remove edges does this right here and this right here. So then what else do you need to do? Well, one thing that you also need to do is it says like subcircuit a circuit in H beginning at a circuit in H beginning at a vertex in H that is also in circuit. Where did we get that vertex, right? Like, how did we know that it was vertex 4 here that they had in common? So we actually had to, um, where did I do that? There was like an asterisk, right? Where did I do it? Okay. Compare H and circuit to see which vertex they have in common. So that's a function too. So I made a function called function find vertex. So it was written this way, e.g. EH. So there's two graphs. You're not necessarily going to call it with G and H. You call it with the appropriate input. But what's it supposed to do? So it just looks through both lists for a vertex that's in both. So it calls it V. The vertex is returned as V. And what's the N? Well, the N is going to be the position in G where you found it. Why? Because think about this. Like when we did this right here, you had to insert the subcircuit right after the 4, right? There was a 4 here, there was a 4 here, and in between goes the subcircuit. So you need to know what row this is in order to insert the subcircuit at the right place. And so the way to do that is just when you call this function, it's going to tell you the right place. So the vertex is returned as V, and what row in EG where it was found is in. Okay, so that can find a vertex now. And then finally, there's a function called merge circuits, where you give it a circuit, you give it a subcircuit, and also you give it a position in. And what it will do is it will simply insert subcircuit into circuit after row in and return the result. And of course, this does this last bit here, right? Subcircuit goes in the middle of circuit, and there's the result. And again, in order to do this, you got to know where to do it. So this was after row 2, but it didn't have to be after row 2. So there's a function for that. And so at that point, if you look up here in the pseudocode, right, we've done everything, right? Because this is the insert the circuit, and that's it. So everything is making a circuit, right? Makes a circuit, removes edges, makes a circuit, removes edges, and then merges circuits into a bigger circuit. So everything is a function. And that lets the pseudocode be basically this long, right? Like the actual code is only looking at the function. The actual code for the main function is 1, 2, 3, 4, 5, 6, 7, 8. 8 lines. And, one of them is an end and one of them is a while. So, like, really, it's like 6 lines of code. Well, we'll say 8. So what's the point there, right? Really, the work is all in these individual tasks, and the individual tasks are much simpler to understand, right? Like coding up the whole thing seems impossible, but like think about this. Like circuit, merge circuit, circuit, subcircuit in, insert subcircuit into circuit after row in, and then return the result, right? Like if you're going to write this code, this will be the last thing we do. Because we're not going to be writing code. But like, so each of these is simple, relatively simple. They're not all simple. Kinda. Right? Like for example, if you actually had to do this, right? Like if you had, like suppose circuit was, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And suppose subcircuit, I'll say SC, was that it can be small. 5, 6, 2, 1, whatever. I don't know why I used 5, 6. Should just do like 9, 9, 9, 9. Something like that, right? Now, this would not be valid input, but I mean, it would not come from this function. But if like in was 3, right? All you've got to do is at that point, you would just say, okay, well, we want 3 rows from circuit, right? Then we want SC. And then when you're done, you go back here, right? And then that's not hard to do in MATLAB, right? The code in order to do that in MATLAB would just be like this. So as a one-liner, what your circuit would be, your new circuit would be, you would need, what would you need? You would need circuit, but if n is 3, you only want 3 rows. So how do you get 3 rows of circuit? Well, the way you get 3 rows from circuit is you say row 1 to n, which is 3 for rows, and then you say every column. That would be this. And then you can just go semicolon. We want SC, SC, and then you want the end, which is circuit n plus 1 to the end, comma, colon. I think that would work. And then that would pick up the last bit there. So there's 3 sections, the beginning, the middle, and the end. And this tells you the position. And you can actually do that in one line in MATLAB. So this function right here, merge circuits, which seems maybe complicated, is not complicated. It's like one line. And each of these is, relatively straightforward to write at least. Okay, so that's what we're going to be doing now. You're going to have a couple of lectures where we kind of like walk through this together, okay? And we'll start that in the next lecture. So I'll see you then.